The problem is I is equal to integral 0 to 1 log 1 plus x by 1 plus x square dx. Okay, this is the problem. How to solve this? See that you have a 1 plus x square below. Okay, and you know that sec square theta is equal to 1 plus tan square theta. I say let x is equal to tan theta. That means dx d theta is sec square theta. That means dx is sec square theta d theta. Therefore, I now the limits will also change because I'm changing the variable from x to theta. At x is equal to 0, you have 0 is equal to tan theta. That means theta is equal to tan inverse 0. That means 0. At x is equal to 1, 1 is equal to tan theta. That means theta is equal to tan inverse 1, which is pi by 4. So therefore, I is equal to integral. Now the limits change from 0 to 1 to 0 to pi by 4 log 1 plus tan theta divided by 1 plus tan square theta, and dx is sec square theta d theta. So this is integral 0 to pi by 4 log 1 plus tan theta divided by sec square theta into sec square theta d theta. Right? So this is
Yes,
integral
sir.
0 to pi by 4. Now sec square will cancel. You only have log 1 plus tan theta d theta. Now the problem is how to evaluate this integral. In fact, this particular integral was given as a separate problem in your ISC questions. That is evaluate integral 0 to pi by 4 1 plus tan x dx. Okay, so this problem is actually this 1 log 1 plus tan theta is in itself a problem. Okay, so know this technique. What you need to do here is you need to apply this property that we have been doing. We can write this as 1 plus tan pi by 4 minus theta. Any questions in this step? We have applied this property.
No, sir.
Let me just show you the property once to refresh your memory. This one. Integral 0 to a fx dx is equal to integral 0 to a fa minus x dx. This property we have worked out a lot of sums. Today the last sum of this property. Okay. So a here is how much? A here is pi by 4. Okay. So that is what we have put. Next what you do here is this is integral 0 to pi by 4 log 1 plus tan pi by 4 minus tan theta divided by 1 plus tan pi by 4 into tan theta. Right? Tan a minus b formula d theta. Integral 0 to pi by 4 log 1 plus 1 minus tan theta divided by 1 plus tan theta d theta. Now you take the LCM within the log. 0 to pi by 4 log, take the LCM, you will get 1 plus tan theta as your LCM. Get 1 plus tan theta plus 1 minus tan theta d theta. What happened? This tan cancels. What are you getting? 0 to pi by 4 log 2 by 1 plus tan theta. 1 plus 1 is 2. 2 by 1 plus tan theta d theta, which is integral 0 to pi by 4 log 2 by 1 plus tan theta can be written as log 2 minus log 1 plus tan theta d theta, which is equal to, now separate the integral, you get integral 0 to pi by 4 log 2 d theta minus integral 0 to pi by 4 log 1 plus tan theta d theta. Now what is this? If you see this, we are getting back I. Now log 2 is a constant, you can take it out of the integration. So log 2 integral 0 to pi by 4 d theta, and the second one is simply I, right? Now you see what you are getting. We started with what?
Yes, sir.
We started with this we started with this I, right?
Yes, sir. Yes, sir.
No, not here. We started with this I. Sorry, this one. We started with this I, right? And we are getting what? We are getting back I here. That means I plus I will become what? Therefore, I plus I is equal to log 2 integral 0 to pi by 4 d theta, which is log 2 theta evaluated between the limits 0 to pi by 4, which is, put the upper limit pi by 4, put the lower limit 0 log 2, which is pi by 4 log 2. Okay.
Okay,
So
sir.
this is what the application of this is. And this was the last application of this. Let us now move on to the next property. Applications of the property of the property. Now, which property are we going to see? We are going to look at the application of property number 4 now. The property is integral 0 to a fx dx is equal to twice integral 0 to a by 2 fx dx if a minus x is equal to fx. Okay, if this is satisfied, only then you can write this. Otherwise, it is equal to 0 if you see f a minus x is equal to minus fx. If f a minus x is equal to minus fx. Okay. So if you are able to check this, then the integral will be equal to this. Otherwise, it will be equal to 0. Straight away, you can write 0. Let us see
Okay, sir.
one or two applications. Let us start with a very simple one. Problem. Let I is equal to integral 0 to 2 pi cos to the power of 5x dx. This. Now see here, if you look at the property here, what do you see? A here is 2 pi, right? First check
Yes,
whether
sir.
this condition is satisfied or not. First check whether this condition is satisfied or not. How do you check? Let fx is equal to cos to the power of 5x. Okay, so here what is the value of a? Here a is 2 pi, right? And the condition is if a minus x is equal to fx, or if a minus x is equal to minus fx. Let's check. Therefore, f a here is 2 pi. So put 2 pi minus x is equal to cos to the power of 5 2 pi minus x, right?
Yes, sir.
And what is the value of cos to the power of 5 2 pi minus x? In fact, this is 0 to a by 2. So a is 2 pi. Okay.
Yes, sir.
If a is 2 pi, so now we have cos to the power of 2 pi minus x. Now what is 2 pi minus x? Cos 2 pi minus x. Which quadrant is in this? Is this angle? This is in the fourth quadrant, right? 2 pi minus x. So
Yes,
this
sir.
becomes, and in the fourth quadrant cos is positive. So it becomes simply cos to the power of 5x, which is the same as fx. So what have you shown here?
Yes, sir.
What have you shown here? You have shown that f a minus x is equal to fx, right? That means this integral now 0 to a fx can be written as, what can it be written as? Therefore, I is equal to integral 0 to 2 pi cos to the power of 5x dx can be written as, we have shown this f 2 pi minus x is equal to fx. This becomes twice integral 0 to pi
Yes, sir.
cos to the power of 5x dx, right? That is what it becomes, right? Now again we check with this property.
Yes, sir.
Again we check. Let fx is equal to cos to the power of 5x. Therefore, what is f? What is a here? A here is this time is pi, right? A here is pi.
Yes, sir.
Here a is equal to pi. So f pi minus x is equal to cos to the power of 5 pi minus x. Now, in which quadrant is this angle? Pi minus x. This is in the second quadrant, right? In which cos is negative. That means this will become minus cos x to the power of 5. That means this is minus cos to the power of 5x, which is minus fx. Now again see, in the first part, we showed that f a minus x is equal to fx when the limit was 0 to 2 pi. In the second part, when the limit is 0 to pi, we have shown this. That means what is the value of the integral? It must be 0. So therefore, you can write hence I is equal to twice integral 0 to pi cos to the power of 5x dx is equal to 0. And what is the reason? Since, let's write it 2 into 0 for better understanding, is equal to 2 into 0, which is equal to 0. Why? Because we have seen that f pi minus x, f a minus x is equal to minus x. We have already shown above here, and you know that f a minus x, if it is equal to minus fx, then we can put it equal to 0. Then we can directly write the integral equal to 0. This was one. Let's see a next one more example from this property. Let I is equal to integral 0 to pi dx by a square cos square x plus b square sin square x. Okay.
Yes, sir.
So I assume here let fx is equal to 1 by a square sin square x plus b square sin square x. Therefore, f a minus x. What is the value of a here? Pi. F pi minus x will be equal to 1 by right here a is equal to pi a square sin square pi minus x plus b square sin square pi minus x, which is equal to 1 by. Now what is sin square pi minus x? Second quadrant, and second quadrant sign is positive. Also there is a square, so it will simply become sin square x plus b square. What is oh sorry, this is not, I've written both as sine. This should be cos. So this is cos square pi minus x. In the second quadrant, pi minus x is in the second quadrant. Cos is negative in the second quadrant, but because there is a square here, so cos remains a cos square x plus b square. Similarly, you have sin square x. That means this is equal to fx. That means we have shown that f pi minus x is equal to fx. So which one is applicable here? According to rule, this one. F pi minus x is equal to fx. So we'll say this is applicable here. So therefore we can write integral 0 to, therefore I is equal to integral 0 to pi dx by a square cos square x plus b square sin square x is equal to twice integral 0 to pi by 2 dx by a square cos square x plus b square sin square x. Right?
Yes, sir.
Now how to evaluate this integral? Again, I have done this kind of an integral when I was doing a substitution method. See, in order to evaluate this kind of an integral, you have a cos here, right? And you have a sine here, isn't it? So what you do is we try to bring a tan. So how do we bring a tan? We divide the numerator and denominator by cos square x. So what do? We have integral 0 to pi by 2. This becomes dx by cos square x, and this becomes a square cos square x by cos square x plus b square sin square x by cos square x. Right? This is what it becomes, which is equal to twice integral 0 to pi by 2 sec square x dx divided by a square plus now b square sin square by cos square. Sin square by cos square is nothing but tan square x. Right? So I brought a tan square, and you know that the ddx of tan x is what? Sec square.
Six
Therefore,
square.
in this integral, I put t is equal to tan x. That means what do I get? dt dx is equal to dt dx is equal to sec square x dx. Sec square x. That means dt is sec square x dx. Therefore, I is equal to twice. Also, you have to change the limits also. So change the limits for x is equal to 0. 0 is equal to tan x. That means x is equal to tan inverse 0. Sorry, t is equal to tan x. T is equal to this tan 0. For x is equal to 0, t is equal to tan 0. Because we are changing the variable to t. That means t is equal to 0. For x is equal to pi by 2, t is equal to tan pi by 2. That means t is equal to infinity, right? Now we have got the limit as infinity. Now that is a problem. Okay, but anyway, let's see how it works out. Which is equal to twice integral. Therefore, I is equal to twice integral sec square x dx. We change the limit to 0 to infinity, and sec square x dx is dt divided by a square plus b square t square, right? This is what it becomes. Okay, now what happens?
Okay, sir.
Now how to evaluate this? You make the coefficient of t square 1. 0 to infinity, divide numerator and denominator by d square plus t square, right? Now what is the integral of this thing, dx by a square plus x square? Again, I have not done this integral. Integral dx by a square plus x square is tan inverse x by a. Okay, that is the formula. So this becomes, instead of so this becomes dt. You can take 1 by b square out, dt by a by b square plus t square. Okay, so that means this is 1 by b square, and this limit is integral 0 to infinity. Now what is, according, if you compare this is your a square, right? And the formula is
Yes,
tan
sir.
inverse x by a. So this becomes tan inverse x by, what is a? It is a by b. And the limits are from 0 to infinity. So this is 1 by b square tan inverse infinity minus tan inverse 0, which is 1 by b square. What is tan inverse infinity? What value of tan is infinity? It is pi by 2
Pi
minus
by
0.
2.
That means pi by 2b square. That is your value. Okay. So these were two applications of this
Okay, sir.
integral. Okay. I move on to the next application of the next property. Application of the property. Now, which property are we going to see? See here. We are going to see the next property here. You see this property, minus a to plus a, property number 6. Fx is an even function, fx is an odd function. I have already shown you one or two examples on these, if you remember. isn't it? I've already shown you in the beginning. Still, we are going to do two or three sums from this. Application of integral minus a to plus a fx dx is equal to twice integral 0 to a fx dx if f minus x is equal to fx. That is, if fx is an even function. Okay, is equal to 0 if f minus x is equal to minus fx. That is, if fx is an odd function. Okay.